Hi there! So today we're going to be reviewing experimental design. And as part of that, we're going to be reviewing a little bit more about randomization and how it works. Now, I know that you probably already have a pretty good grasp on randomization, but it's important to review. And you'd be surprised, sometimes I'll ask seniors and juniors what randomization does, and it's kind of hard sometimes for them to articulate it. So I think it's important for us to go through this particular concept with just a little bit more detail and do an activity. So to review some concepts, internal validity is our ability to determine causation. And sometimes there are threats to internal validity. We'll get much more into specific threats to internal validity a little bit later once we go through quasi-experimental designs. But for now, we're going to talk about how we determine causation to have good internal validity. A confounding validity is a variable that varies along with the independent variable. So a confound would be something that is a potential alternative cause. The example is that when we went through in class, we talked through Montessori versus public schools and how they might differ in more than just method of delivery. Because the Montessori school has a tuition associated with it, the students who go there might be from a higher socioeconomic status, which means that the two groups differ on more than one thing, and it's difficult to determine whether the actual cause of improvement is method of delivery or socioeconomic status providing additional assistance. Another term I want you to be familiar with is that of selection differences. That just says that groups should not differ from one another in systematic ways. That if they do differ from one another in systematic ways, then that could be a potential confound. So let's go ahead and review a little bit about the necessary conditions for what makes a study experimental and how we determine causation, because this is at the heart of experimental design when it comes to true experiments. So our ability to determine causation is determined by three different factors. This is review. We went through this during week 1, but let's go ahead and revisit it again. The first is temporal precedence. With temporal precedence, the cause comes before the effect. So if you have a hypothesis that flicking the light switch causes the lights to turn on and off, then you should flick the light switch and the lights should turn on and off. They shouldn't turn on and off before you flick the light switch. Covariation is when the effect occurs when the cause is present, and also the other way around. The effect does not occur when the cause is absent. So the light should flicker every time you flick the switch, and the light should not flicker when you are not touching the switch. And the last thing is the elimination of alternative causes, where you are sure that the effect is only due to the cause. You've double-checked to make sure that there's no joker hiding behind the door, connecting and disconnecting the electricity in time with your flicking the switch just to mess with you. So we use different tools in order to establish causation when we are using a true experimental design. First of all, we have manipulation of variables so that there's two different conditions. Now, I know that some people get a little hung up on experimental versus control. When we have a control condition, that doesn't necessarily mean that it's a true neutral. Sometimes it's just a comparison. But regardless, there are two different conditions that we can compare to one another. We've randomly assigned people to those conditions, and we'll come back to random assignment and dig a little deeper with that. And the two groups only differ on one thing, and the one thing they differ on is controlled by the experimenter. This is a pure experiment and the best way to establish causation by eliminating confounds. Once again, if we've randomly assigned, we can assume that the two groups are roughly equal to one another and that they don't differ on additional underlying differences. So let's go ahead and review how random assignment does that. So I would like you to do an activity here where you either go to the website, and I'm going to go ahead and link this to Canvas as well, or you can get out a deck of cards and shuffle them yourself. The website does it randomly, so you'll know it's very well shuffled. But if you like to have that tactile sensation of shuffling the deck yourself, and it might be fun, then you can go ahead and get that out, take out all the jokers, and shuffle it very well. And then I would like you to choose 26 cards, which is half of the deck of cards. And I would like you to count how many face cards there are. There should be about 8. How many cards there are between 2 and 10. There should be about 18. And how many red cards there are. There should be about 13. And I want you to do this activity a couple of times to see each time what your answer to those 3 questions is. I'm going to go ahead and post a thread on the discussion forum for this week that has you comment with the results of your particular activity. I think if enough of us do this enough times, we'll start to see a very clear pattern emerge, and it should be pretty interesting. I'm actually a little bit bummed because I was hoping to do this in class and to have like a whole bunch of decks of cards around and have you work in groups and teams and do this, but we're just going to have you do it on your own. I also want you to go ahead and choose 52 cards from a 2 shuffled deck. So the website lets you select how many decks you can use, so you can go ahead and do that with 52. So for example, just very quickly, let me see. Oh, I don't know if it'll let me go off-site. Anyways, you'll want to select 26 cards from a single deck without selecting the jokers. As you're going through this, I want you to think of a few things. The first is that you're not always going to get 8 face cards or 13 red cards. Sometimes you might get 7 face cards or 9 face cards. It's a little bit more rare, but sometimes you might get 6 face cards or 10 face cards. And the key thing here is that on average, the results should turn out as expected. So on the most of your times, you'll get right around 8. And if you average it all together, you'll get 8 face cards on average. And I want you to think a little bit more about how this might represent different participant situations. So for example, if you imagine that the red face cards are female and the black face cards, not the face cards, let me go ahead and rewind a little bit. All the black cards are male and all the red cards are female. There we go. Then about 50% of it should be black cards and 50% should be red cards. And so if you can imagine that it would be important for you to have a roughly equal number of males and females in your 2 different conditions, then you can imagine the red and the black cards as representing that binary gender in its simplest form. And that is a way to ensure that you have a roughly equal number for each in your groups. I also want you to imagine that the face cards, there we go, are representing something a little rarer. For example, someone that has a learning disability, or someone who has a higher socioeconomic status, or is a first-generation college student, or is a minority student. And if you're thinking about splitting these 2 groups into roughly equal conditions, those face cards represent that rarer individual difference, and ensures that even that is roughly evenly spread among the different groups. So this not only does randomization in terms of making sure the groups are even for very broad things, but also for finer individual differences, some of which you might not even think to measure, and it roughly evenly divides them. Also, on a side note, the more cards you have in your deck, the better randomization works. So your results should be a little bit more consistent with the 2-deck model than with the 1-deck model. Randomization works best when your sample size is large. That's just kind of the way it works. So for example, if you only had 10 people and you were randomly assigning them to groups of 5 and 5, it wouldn't be as set in terms of whether they were even among the groups. There's going to be a little bit more variety. But if you had 100 people and you were randomly assigning them to 50 and 50, it would be a lot more even. So that's something else to think about. The number of people in your sample determines how effective randomization is. It's not a perfect solution when you have a small sample size. And that is our brief refresher on randomization.